Okay, a bead is formed from a sphere of radius 2 by drilling through a diameter of the sphere with a drill bit of a radius 1. Find the volume of the bead. So this problem, uh, let's say, let me draw. So we have a sphere of radius 2. So I'm going to just draw a sphere on paper. So it would be actually just a circle. You can see that circle. And if you try to write down the equation of the circle or equation of the sphere with the radius 2, center at origin, you can see the origin. The equation would be x squared plus y squared equal 2. Okay, and we are planning to drill uh, with uh, drilling through a diameter of the sphere with a drill bit of radius 1. So let's just, place that sphere, a circle, center at origin. I almost forgot, it should be 2 square. So now we're trying to drill here with the radius 1. So after drilling, this is what we're going to get. This is the structure. It's going to be gone from the sphere. And the leftover would be this part. I'm going to use different color here. So the leftover after drilling would be this blue portion, both sides. Okay, and we need to find out the volume of this blue portion. So if I try to use one of the method we have learned to find the volume of this kind of a structure, then I just have to, let's say, I just need one part of this portion here. So I just need this part. Okay, if I can find out the volume of the, if I just revolve this part around y-axis, and if I find the volume of that revolution, then that would be the volume of this bead. Okay, so we are going to revolve this thing around y-axis, and that will help us to find out the volume. And in this problem, I'm going to use the washer method. So for the washer method, you can use the cell method as well, or you can use the washer method. And for the washer method, the volume can be found by using this formula. The volume can be found by using this formula, pi, the volume of washer. Let's say we draw a washer here. This is the washer. And we're going to just revolve this washer around y-axis. And after that, the picture we're going to get after revolution of this washer would be this. You can see that there is an inner circle and outer circle. So the volume of this washer would be pi. The radius of outer circle square minus the radius of inner circle square times the height of that washer. So in this case, because we're finding the volume from this point to this point, we're going to integrate this thing from, now here we're trying to use the variable y. So we're going from y value of this point to this point. So let's find out that y value, let's say a to b for now, and then radius of outer circle minus the radius of inner circle times dy. the radius of outer circle minus radius of inner circle, which would be function of y times dy. This dy is actually the height of this washer. So that's why it's a dy. So now the goal is to find out this range of integration and this radius. So to find out the radius, you can see here, the radius of inner circle would be the distance from this point to this point, which is 1, because if you look at this first picture, we're drilling this sphere using a drill of radius 1. So from this point to this point, the distance would be 1. So from here to here, the distance would be 1. Okay, 1 radius drill. So now that's the inner circle, that's r, small r. And for the capital R, you can see that that's the distance from this point to outer curve, which is actually the x value. So as we know that the outer curve can be represented by this sphere. So if you want to express, your x value in terms of y, then it would be x square equal 2 square minus y square. So x equal square root of 2 square minus y square. But we need x square because the radius is x square here. So let me just copy that one here. The volume would be pi times, we still have to find out this limit of integration. The outer radius r is the value of x, but we need the x square. So x square from this calculation, from the calculation on the here, the x square is 4 minus y square. And let me just, and then minus small r square is minus 1 df1. So this is actually from a to b 3 minus y square dy. So now the main thing is we need to find out the limit of integration. So the limit of integration goes from this point, the y value, x is 1 and y is, we don't know, to this point where x is 1 and then y is, we can find out the y by using the very same, equation of a sphere. If x is 1, then y square is 2 square minus x square, which is 4 minus 1, which is 3. So there are two y values when x is 1 on the sphere. Y would be plus and minus square root of 3. So the lower limit and upper limit would be from negative square root of 3 to positive square root of 3. So here it would be negative square root of 3 to positive square root of 3. If you try to integrate this one, then the integration would be 3y minus y cube over 3 from negative square root of 3 to positive 3. So if you plug the value of this 2 times pi, instead of positive square root of 3, you can just start from 0 because it's double. Are the very same thing from going from negative 8 to positive. So I just multiply it by 2. So if I root of 3 and 3, and if you put 0 here, it would be just 0. So even it would be 3 square root of 3, 3 square root of 3, and if you cancel this square root of, so what I'm getting here, y square is y cube over 3, 3 and 3 cancel. 3 square root of 3 is 3 times this cube root of 3 minus 1 cube root of 3 gives you 2 cube root of 3. So volume of the bit, we're going to get is 2 with the drill of this answer. Actually, there is an error in the the options we have given in the exam one. This answer is not available. What I'm going to do is I'm going to give everyone the point for this particular problem if they miss this problem, because this answer does not give choices for that particular problem. I hope you understood this work or explanation. If not, then just feel free to email me back.